Welcome back to The Explainer. Today, we're zeroing in on a massive, monumental paradigm shift happening right now in the tech world. I mean, we've all seen how the artificial intelligence boom has completely revolutionized the digital space, right? But today, we're talking about the next frontier, the leap from digital AI to physical AI. We're going to break down how a startup called Generalist is literally building the universal brain to power the physical robots of our future. Okay, let's dive right into this because this really is the billion-dollar question. You've probably noticed it's super easy for a large language model to write complex Python code in seconds or, pass the bar exam. But if you ask a state-of-the-art robot to reliably fold a t-shirt or pack a cardboard box with the correct amount of force, it completely falls apart. And that's because, for decades, roboticists have been trapped. They've been stuck by the rigid limits of hand-coding software, meaning every single movement, every angle, every ounce of pressure had to be explicitly programmed. So we end up with this crazy contrast between the two realms. The digital world has this incredibly fluid, adaptable intelligence, but the physical world is still plagued by, robotic clumsiness. And the root cause here is actually data. To build a language model, developers can just scrape the entire internet, billions of parameters of human text, and feed it right to an AI. But you absolutely cannot scrape the internet for physical dexterity. There's no massive database out there that tells a computer what it physically feels like to grasp a delicate glass or manipulate a flexible cable. Which brings us to a massive data bottleneck. While LLMs get to feast on all that internet text, robotics training data historically just hasn't existed. But the founders behind Generalist, and these folks have serious backgrounds spanning MIT, Boston Dynamics, and applied physics, they realized that to break this bottleneck, robotics had to enter a totally new pre-training era. And since the data wasn't there, they realized they had to manufacture their own physical data completely from scratch. So, how do you actually manufacture physical data? The mechanics here are absolutely fascinating. Step one, they built these specialized handheld devices called data hands. Think of them as deliberately simple pieces of hardware that a human operator holds to interact with the world, basically digitizing human dexterity. Step two, they logged hundreds of thousands of hours of these proprietary physical movements across tons of different scenarios. And finally, step three, they take that vast well of captured human experience and use it to train a general robotics foundation model from the ground up. Just look at the scale of this number, 500,000. Generalist has amassed 500,000 hours of dexterous robotics data. It's honestly mind-boggling. Because they put in the grassroots effort to capture all this human physical experience, they are essentially the only ones with the resources to ask the big question. What actually happens when you train a foundation model on 500,000 hours of raw physical dexterity data? Well, the market is certainly answering that question. This proprietary data collection system they built is incredibly valuable. Venture capital firms led by Spark Capital looked at this and realized Generalist's unique ability to gather this data is their ultimate superpower. That realization drove a massive $140 million raise at a $440 million valuation. Investors clearly saw this team had that rare, perfect mix of research and robotics capabilities required to actually breathe life into this scaling hypothesis. So, here is the absolutely crucial takeaway. We are witnessing the death of traditional, hand-coded software in robotics. It's a total game changer. For years, engineers spent their days doing brutal, repetitive manual labor, trying to write brittle, line-by-line instructions for robots. Foundation models completely wipe out that old way of thinking. Instead of explicitly telling the robot how to move, you just give it a pre-trained brain that intuitively understands how to move, drawing on its massive library of physical data. To give you a real-world picture of this in action, Generalist recently showed off their Gen 1 model servicing a robot vacuum, and it's incredibly complex. The robot instinctively knows the exact, delicate force needed to remove parts without snapping them. It's using seamless two-handed coordination, doing these dynamic, flipping maneuvers, and here's the kicker. It is drawing purely on its pre-trained experience. Nobody would ever sit down and use traditional code to attempt these complicated little tweaks because, frankly, it would just be entirely too fragile. And this brilliantly illustrates a concept that researchers have been chasing for decades: physical common sense. As humans, we take this for granted, right? If an object slips in your hand, your fingers automatically make these subtle micro-corrections so you don't drop it. You have a reactive, improvisational intelligence. Well, thanks to this massive influx of physical data, robots are finally developing this exact kind of physical common sense, which allows them to recover from unexpected errors right on their feet. There's actually this perfect anecdote from the team that hits the nail on the head regarding the exact moment the old paradigm failed. The engineering team was working on a task involving flexible belts. Now, flexible objects are notoriously difficult to model mathematically. One of the team members literally just looked at the task and said, "I cannot program this. I do not know how to write software to do this." Let's see how this translates into a real-world test. Because they couldn't write the software, they just showed the model how to do it using their pre-trained base. And the result? The robot became so incredibly resilient at manipulating these flexible belts that the team could literally snack the robot's hands with a hockey stick mid-task. Because it was trained with physical common sense rather than being rigidly coded, the robot didn't crash or freeze up. It just seamlessly reacted, fixed the error, and kept working. That right there is the absolute magic of the pre-training era. Now, what's really interesting is how they're turning this technological breakthrough into a strategy for mass adoption. Generalist knows that doing impressive lab tricks isn't the end goal. Hardware is inherently tough to build, and global supply chains can easily crush your growth. So their philosophy relies heavily on the Pareto distribution. They are focusing on simple, first principles design to capture 80% of the capabilities, intentionally stepping away from the over-engineered, highly complex hardware that is just impossible to scale. This entire strategy for mass adoption is all about simplicity. They want to avoid the classic bundle of wires prototype trap that plagues so many robotics labs. The goal is to build a product that you literally don't need a PhD to turn on and operate. By empowering strong technical founders with technology that actually works reliably out in the real world, they are dramatically lowering the barrier to entry and pushing this tech much closer to the broader market. And because we are finally in this true robotics pre-training era, the speed of innovation is just staggering. Just check out this timeline. They announced their Gen 0 model in November. By April, just a handful of months later, they rolled out the Gen 1 model, demonstrating massive, rapid improvements. We are now living in a world of predictable, ongoing model scaling. Just like we watched LLMs get predictably smarter with every generation, physical AI is now on that exact same explosive trajectory. Which brings us to Generalist's ultimate grand vision, building the universal intelligence layer. Their goal isn't necessarily to manufacture every single robot in the world. That'd be impossible. Instead, they want to be the underlying application layer. They want Generalist to be the foundational brain functioning inside everyone else's hardware, powering a diverse global ecosystem of incredibly useful robots. I want you to really stop and think about this for a second. What actually happens when billions of robots share one highly adaptable foundation model? Just as the digital AI boom required massive new hyperscale infrastructure, the physical AI boom is going to require universal adaptable brains capable of navigating an infinite variety of physical tasks across the globe. We are talking about a fundamental shift in how physical work is accomplished on this planet. And this leads to a truly visionary outcome. As they noted, there's going to be a Cambrian explosion of people, entrepreneurs, and developers building creative ideas on top of these robotic foundation models. By providing a universal intelligence layer that actually works out of the box, Generalist is handing developers the tools to unlock entirely new industries. People who previously had zero robotics experience are going to be able to build wildly creative physical applications simply by leveraging this pre-trained brain. Which leaves us with this final kind of mind-bending thought. Today, we are completely used to interacting with a language model, throwing it a prompt, and getting 5 different essays in a matter of seconds. Very, very soon, we're looking at a future where you will communicate with a physical AI system, give it a prompt, and it will effortlessly construct 5 different physical prototypes for you to choose from, when physical creation becomes just as instant and fluid as digital generation. What will you build? Thanks so much for joining me for this explainer, and I'll catch you next time as we continue to break down the future.